197. What is the molar solubility of PbOH2 in a 0.138 molar solution of CH3NH2? Okay, now in order to answer this question, I did have to go in the back of a textbook to find out a couple of constants. Now they're asking for the molar solubility of PbOH2. Whenever they're talking about molar solubility, that's saturated solutions, solubilities, that's a KSP, solubility product. So I found the solubility product of PbOH2 of 1.2 times 10 to the negative 15th. So for every KSP, we have to write a balanced equation. So let's just write it out now. So we have PbOH2, and remember, with KSPs, the compound is always going to start with a solid, and this is going to break down into its two ions, right? Hydroxide is always together, then you have the lead, the Pb. So this would be Pb plus OH. You could use those subscripts to help you out with the charges. You had one Pb and two OHs, crisscross them up, right? So Pb is a +2, and hydroxide is a -1. They're both charges, so that means that they're both aqueous. And now just make sure that it's balanced. I do notice that I have two hydroxides, so I have to just put a 2 in front of the OH, and we're good with that. I'm just going to take this KSP value and bring it down over here. And then let's just write out the expression, because chances are we're probably going to have to use it at some point. So remember, KSP equals just the concentration of the products. No solids allowed. So I have Pb 2+ times the concentration of OH minus. And since it is a 2 in front, I do have to take the OH minus and raise it to the second. Now, let's do the same thing for the other constant that I found in the back of the textbook. CH3NH2. Well, NH3 is ammonia, right? And we're just adding like a methyl group on here. So chances are this is acting as a base, just like ammonia would as well. And when I did search, I did find a Kb value, 4.4 times 10 to the negative 4th. So this has to be a base because it's with the Kb, B for base. So let's just write the balanced equation. Now with acids and bases, specifically bases, you start with your base, CH3NH2, and that's going to be aqueous. With bases, you always react them with water to get that balanced equation, but water is liquid. Comes to equilibrium, the base is always going to grab a hydrogen, so this is going to become CH3, NH3 plus, and then the H2O is going to lose the hydrogen, which is OH minus. They're both charges, so they're both aqueous. And it's all balanced here. So I'm just going to bring the Kb over here. And just like we did before, let's just quickly write out the actual expression, because chances are we're going to need it, right? This is equal to concentrations of products over reactants. All aqueous here, no water allowed. So it'd be CH3, NH3 plus times OH minus divided by CH3NH2. Cool. Okay. Now, well, why do we have two equations? Well, we want to find PbOH2. So probably at the end of the day, we have to use this part of the question. And they're giving me information that leads to the CH3NH2. They said that we're at 0.138 molar of CH3NH2. So there has to be some similarity between these two equations. What is it? What's the one ion that's the same? Yeah, you're absolutely right. It's the OH minus, right? That's the tie between the two of them. Since we have more information for CH3NH2, I can find out the OH minus to plug in to this equation. And now I transfer it over and I'm in the right equation that I need to be in. So let's just bring this down because I can't use that right now. I have to use the information that was given to me. So maybe I will bring this a little bit up. And now let's work with it. Now, they said that we were, starting with a 0.138 molar solution of this. Keep in mind with these questions, these are always going to be your initial initial concentrations. And whenever they give you initials, we have to think of ice table. So let's ice it out. I'll bring this down a little bit. Okay, ICE. Initially, for I, they only told us that we have 1.38 of methylamine, right? CH3NH2. So I'm going to put the 0.138 here. So this is liquid. This has nothing to do with equilibrium, so get rid of that. But I didn't start with any of the products. So 0 and 0. You can only go up from the 0 side, so that side is always going to be positive. And in this case, the reactants are going to be minus or negative, right? Coming down. We don't know by how much, so therefore we just like to use a variable. We use x. So this would be minus x, and plus x. And then equilibrium, you just pull them all together. So 0.138 minus x is 0.138 minus x. 0 plus x is x. 0 plus x is x. And these three pieces of information, this one, the x, and the x, they're all going in your equilibrium expression. So this is x, so is the OH minus, and this is 0.138 minus x. Now, generally, we do like to assume, right? Whenever we have a number with the minus x, we say to ourselves, okay, this number is small, so whatever we started with, chances are we're going to be ending with roughly the same amount. But now we're getting into a little gray area because usually it starts with 10 to the negative 4, right? And then as you get to lower numbers, 10 to the negative 5th, 10 to the negative 6th, then we can definitely assume. But 10 to the negative 4 is a little iffy. Now, if you want, go and try it. Let's assume that it's x, right? Do the whole shebang and solve for x. Then do your 5%. If you get higher than 5, you can't assume. And with this equation, you're going to get a number higher than 5. So I'm just going to say, oopsie, we can't assume, and we have to keep the minus x into our expression, which unfortunately leads to the quadratic equation, but we got to do it, right? So let's go for it. 4.4 times 10 to the negative 4th equals, we get the x times x divided by 0.138 minus x. So cross multiplication, this times this, and then it's going to turn into distributing, right? Because it's basically 4.4 times 10 to the negative 4th, oopsie, not equals, this times 0.138 minus x equals x times x is x squared. So let's just distribute. You got to be fair. So this turns into, let's actually see. 4.4 times 10 to the negative 4th times 0.138. I get 6.072 times 10 to the negative 5th minus 4.4 times 10 to the negative 4th x. And this all equals x squared. Maybe I'll put that in black. Okay. So, since we're starting with the quadratic, I have an x value, I have an x squared. I have to move all my information to one side of the equal sign. Generally, students like to have a positive x squared. So what I'll do is I'll take these and move them to the x squared side. So if that's the case, we're going to plus 4.4 times 10 to the negative 4th x on both sides times 10 to the negative 4th x. And then we will minus 6.072 times 10 to the negative 5th on both sides. 6.072 times 10 to the negative 5th. And with that, this cancels. and this cancels, and the whole thing equals 0. So I'm just going to start over here. So in essence, we have 0 equals x squared. So maybe I'll color code this now. So I'll say x squared plus the 4.4 times 10 to the negative 4th. And then this would be minus 6.072 times 10 to the negative 5th. And here now we have to pick out our A, B, and C because that's going to be the letters that you plug in into your quadratic equation. So remember, the A is the number in front of the x squared. There was no number in front of the x squared, so that means that it was just 1, right? 1x squared. So A equals 1. B is the number in front, and what happened to that x value? I just want to make sure. Yep, okay, that had the x. I see that over here. I'm just going to squeeze that in. Boop. So it's the number right in front of the x value. Just make sure that you have your, what is this called? The sign, right? Just make sure that it's either positive or negative. So 4.4 times 10 to the negative 4th. And then your C value is just the value that's chilling at the end. So C equals negative. It's a negative. So negative 6.072 times 10 to the negative 5th. And now I'm going to use my quadratic equation, which is this. X squared equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go for it. X equals a long division. Negative b. So the b was 4.4 times 10 to the negative 4th. And then it's plus or minus the square root of b squared. So there goes the b again. So 4.4 times 10 to the negative 4th. And that's squared. Minus 4 times a, and a was 1, times c, which is a negative 6.072 times 10 to the negative 5th, all over 2 times a, which is just 1. Now, I'm just going to simplify off of this. If you want to keep writing underneath every step of the way, that's fine. The first thing you should do is get this whole thing under the radical as one number. So you can plug it into the calculator or use 2 steps. But I'm just going to plug it into the calculator, and let's see if your answer matches mine. So 4.4 times 10 to the negative 4th, I'm going to square that. Minus 4 times a negative 6.072 times 10 to the negative 5th. And I believe I punched in everything correctly. So I'm just going to erase all this. Beautiful. Oop. Let's see. So now we get 2.430,736 times 10 to the negative 4th. You could also just simplify 2 times 1. Obviously, 2 times 1 is just 2. Now take the square root. What's the square root of that number? Okay, a long decimal. So I'm going to try to add as many numbers as I can. I'm just going to keep chipping away here. So I get 0.0155908. That should be good enough. Okay, get rid of all this. Now remember, we're dealing with concentration values. At the end of the day, these concentrations can't be negative. They can only be positive. So we have 2 answers here. One that's adding these 2 numbers together, and one that's subtracting these 2 numbers. I want the positive one. Which one of these is going to give me the positive answer? It's the plus. If you use the negative or the minus, you will see that you will get a negative answer. So I'm just going to plus these together. Negative 4.4 times 10 to the negative 4th plus 0.0155908. And I'm just going to erase that. We're getting closer to that X value. So this is just 0.015. Wait, am I doing this right? 0.0151508. And now this is all divided by 2. So I get X equals, I'll say 7.5754 times 10 to the negative third. Okay, and that's molarity. Now remember, the link between the two is the hydroxide ion. So I only care about what the hydroxide is in this case. And the hydroxide was just X. So if I just bring this down a little bit, I can say that the hydroxide ion concentration that I care about is 7.57574 times 10 to the negative third. Okay. Whoop. Now we're going to use that information to put it into this equation. Now pause the video if you need to. I just need to get rid of some things here. Let's see. I'm going to get rid of this math. So just pause if you need the math. That's kind of going bye-bye. This was highlighted, I believe. I'm going to get rid of the quadratic because we don't need it anymore. And I guess I'll get rid of this actual, but you could always just pause the video, go back just in case you need to get those answers. Okay, so now remember, this is the hydroxide ion concentration. Don't fall into the trick that since in this equation there's 2 of them, I have to times this number by 2. Please don't fall for the trick. Who cares what the coefficient is in the balanced equation? Whatever you got in real life, that's the number you have. So the hydroxide ion concentration I have is 7.57574 7575. Oh, no 7 here. I'm just looking back at my answer. This would just be a 4. I was like, I looked at it. I said, wait a minute. Oh, I guess I just have to color that in. There we go. Brand new, right? 75754. So 75754 times 10 to the negative third. So what's the PB concentration? I don't know. So label that as X. Now use these pieces of information to plug it in for your KSP equation. So PB is going to be X, and the OH minus is 7.5754 times 10 to the negative third. Okay, so 1.2 times 10 to the negative 15th equals X times 7.5754 times 10 to the negative third, and that's squared. So I'm just going to simplify that. What is that squared? I get a long decimal, so I'll cut it after a couple of them. Just going to simplify this. This is now 5.738667. That's good enough. Times 10 to the negative 5th. So if we just want to get X by itself, all we got to do is just divide by that number on both sides, right? I'm going to divide by 5.73867 times 10 to the negative 5th. Divide by 5.73867 times 10 to the negative 5th. That's going to cancel out, and you're just left with X. So let's see, 1.2 times 10 to the negative 15th divided by 5.73867 times 10 to the negative 5th. And I guess 3 sig figs, 2.09 times 10 to the negative 11th. And that's molarity. But now what's the answer? Well, they wanted molar solubility of PbOH2. Now, just because PbOH2 wasn't in your K expression, it still got a molarity, right? And in your equation, you only had one PbOH2. And this was only one X. So the ratio matches. So when you solve for X, that's always going to be the molar solubility for KSP problems. So in this case, it's the same number, 2.09 times 10 to the negative 11th molarity of PbOH2. And that's it. Whoop, whoop. Okay. What do you think? This one was crazy. I love the quadratic, don't you? Anyway, I hope we're done with the quadratic for a while, but if we aren't, I will most definitely do it for you guys. All right? And if you wouldn't mind, please press the subscribe button. Thank you so much. I'll talk to you later. Okay, bye-bye.